okay? Thumbs up?
Yeah, looking good.
Thumbs up. All right. So I'm more than happy to answer more questions about the Candela projects. It was a great project. It was a fun project. It was an interesting project. I'd be happy to answer questions. I would like to propose that we change the discussion a little bit for this second half, for this second hour. And I'd like to talk specifically to the Passive House designers and engineers in the audience. And I'd like to make a couple statements, ask a couple questions, and I really am interested in hearing people's feedback and their thoughts. To kick that off, I'd like to just start with this quote right here. This was from a Rocky Mountain Institute paper from last year, and it sort of stuck with me for obvious reasons. And they point out rightly, I think, that if we're really serious about meeting our climate goals, that's going to mean something like 5 million building retrofits a year to a zero emissions level. So 5 million buildings every year for 10 years. So I know this is a happy hour, so everybody's got a couple beers in them, I would hope by now. So I'll do the math. How'd they get that number? It's about 113 million buildings in the US. You want to retrofit 50% of them over 10 years? There's your 5 million buildings a year. Well, what does that mean? Like, what does that, I put that in human numbers. It's about 400,000 buildings every month, or to put it a slightly different way, it's about 13,000 building retrofits to a zero emissions level every single day for 10 years. So make it even more real, if you're an architect or a designer working in the US, there's about 21,000 architecture companies in the US. Those are US numbers on the screen there. That would mean that your firm would be responsible for about 250 zero emissions building retrofits every single year for 10 years, assuming that architects were going to be involved in every one of those, of course, which isn't always true, but let's say for the purposes of argument, this is the orders of magnitude that we're talking about. Now, that's a big challenge. That's a big undertaking, obviously. What I would really like to ask, or what I'd really like to talk about on this call now, is not so much about the policy or the sort of finance challenges there, but on our side of the equation as designers, engineers, architects, on the tools and design and process side of the question. And I'd like to just ask and pose as a question to everyone on the call right now, like just as a thought experiment, set aside those enormous policy and financing challenges just for a second. Let's just, for purposes of argument, say the finance people get their shit together. They come to us someday and they say, guys, we found the money. It was between the couch cushions. It's time to get building. Let's go. I want to ask if you could scale up your own Passive House design and engineering process to handle even a fraction of that demand, even a fraction of that amount of work. Could you do it? Seriously, given how hard you work now, given the amount of hours that you work now, given the amount of time that you work now, given how little you see your kids now, could you do it? Could you really scale up your process to accurately, efficiently, and quickly output that level of work? And given that your name is going to go on every document that goes out the door, would you stand behind it? Would you be confident that it's accurate? And what would it take to actually do it well? Could you? Yeah, no, that's what I thought. It's going to take a century's worth of Saturday work in order to meet a challenge like that, given our current process and timeline for Passive House projects. Now, that's not true of everybody's firms. Some of you guys are amazing firms. Maybe you're thinking to yourself, that's fine. I could totally do that. We could do 250 zero emissions buildings tomorrow. If so, awesome. But most of the firms, myself included, we would mightily struggle to attempt even anything close. So I want to ask, in the few minutes that we have together as a sort of community here, what kind of techniques can we use to improve our own accuracy and our speed? How can we get better? How can we do a better job of doing our job? How can we deliver better projects? How can we do more of them better and faster? And I don't know the answer, but I'd like to offer just one partial solution that has worked really well for us in the past. I'll offer a couple examples, and then, as I said, what I'd really like to do is hear other people's thoughts and opinions on these kind of things. So the solution that I'm going to offer here comes from a completely different industry. I actually started out as a builder long before I ever became an architect, long before I ever started doing Passive House projects. In the construction industry, and in particular in the woodworking industry, there's this idea of a jig. It's a really simple idea. Sometimes you have to do something really hard. Sometimes you have to do something many times. Sometimes you have to do something really fast. So you take some time and you make yourself something kind of sloppy, something fast, something quick, often kind of imperfect, to help you do your job better, faster, more accurately. And I'd like to ask or pose the question, could that idea, could that model, could that metaphor be applied to the design profession? And I'd like to suggest that digital workers, those of us who sit in front of a computer all day, need to develop enough skill with our own tool to create our own small, quick, often really imperfect digital helpers or tools to help us do our jobs better. We're going to even come close to achieving the type of, or satisfying the type of demand that we think we're going to see over the next 10 years. I think we're all going to need to improve our skills dramatically. What do I mean by that? Well, let me offer two small examples. I'll offer one really small example and then one slightly larger example, and then I'll shut up. Let's take a problem that we run into all the time. You're going to deliver zero energy buildings. You need to model them effectively. We're modeling these buildings. It's a huge amount of data. The data is not getting smaller. The amount of data is not going down. We need to figure out how to manage immense amounts of data. Okay, that's a big problem. That's a large problem. Let's make it more specific, take it down to a really specific level. How do I manage room level data? Room numbers, room names, TFA, floor area, volume, fresh air flow rates, air handling hookups, all of the various bits and pieces of information at a room level that I might need to manage in a building information model. What tool do I use to do that? Do I use a spreadsheet? Do I copy and paste things from here to there? Well, there's not really a tool, is there? I mean, maybe there is. Maybe you guys have one. I'd love to hear about it, but I don't know of a tool that does that really well in a passive house context. So let's make one. Right? We're working in Sketchup. We're doing WFI plus modeling. We're doing design pH modeling. We're using Sketchup. That's a fine tool. It's not a great tool. It's a fine tool. So let's build ourselves a little digital helper. It's about 2,000 lines of code. It's fast. It's quick. It's easy. It's not very sexy. It's not a piece of software. It's a small digital helper to help us do our job better. And always with an eye towards data flow. The data that flows in has to flow out. It has to flow out to something useful. It can't stop in the Excel model or the WFI model. It has to flow out to a document, it has to flow out to an actual piece of paper that can be used in a certification context. So we build the tool so that all of that data flows seamlessly from end to end. How might we use this? Well, we're using it every day on projects. So this is the kind of tool we build. We use it on all of our projects to help us do our job better, faster, more accurately. This is a renovation project in Manhattan we're working on, Mike Ingwe and his team. Great project, commercial on the bottom, residential up above, multifamily, mezzanine levels, complex interior floor plate. How do you manage it? How do you manage the data? You gonna make a spreadsheet, copy and paste? No, you're gonna make yourself a building information model. If there's not a tool that exists that allows you to manage the information you need to manage, you're gonna build yourself a tool. And you're always gonna do it with an eye towards data flow. So all the data that flows in has to seamlessly flow into both the physics model, so the energy model, and your final certification documentation and your error checking documentation on the back end. We're not going to do things like write tags about information. We're going to make it so that the data actually flows seamlessly into those tags. The computer does the hard work of remembering all this stuff because you won't remember it. I know I won't remember it. I'll do it wrong. I'll type it in wrong. I'll get a decimal in the wrong place. We're going to make the computer do the hard work there. That's one super small example. That's one really hyper local example of the type of thing that we're talking about. Let me just offer a slightly more extended example. This is the workflow that we're working with right now. So for most of our projects nowadays, we've shifted platforms away from SketchUp, not to get too off into the weeds on the tools. SketchUp doesn't seem to be a great tool for data management. We're using Rhino. It's a much more robust information and data management platform. It allows us to do a lot more things, a lot more customizable, a lot more transparent. That's a really important quality in all of our tools that we prize. We're using this to simultaneously create dynamic models and PHPP models from a single source building information model. We're using a tool that we internally call IDF to PH. If you do Energy Plus modeling, you know IDF files. So we're able to translate back and forth between IDF files and passive house files or PHPP files. But the important thing here is not the physics modeling. That's all pretty well understood at this point. That's pretty well managed. The important piece here is about the data flow in and the data flow out. So we have a whole new set of tools that we're using to push data in and manage data. And then just as importantly on the back end, we've got a bunch of data flowing out into an automated reporting tool. So in particular, we're using a web-based reporting tool. So, yes, we used to do, and we still do, quite a few PDF reports, make a bunch of Excel graphs. That's not great, right? That's not a great process. That's not very automatic, and it's time consuming. It's prone to user error. It would be much better if we could come up with a process where the data flows seamlessly from your data in your building information model through the physics model and manages the fire hose of data that comes out of those physics engines, those physics models, whether it's PHPP or Energy Plus or what have you. So we do an automatic web-based reporting that parses through the data, scrubs the data, turns it into something human readable and manageable. What does that look like? It's really straightforward, right? So there is no building information management tool to do that in Rhino currently. Okay, fine, build yourself one. So a couple thousand lines of code. You're gonna manage component libraries, windows, surfaces, TFA, domestic hot water, thermal bridges. It's no different than design PH. It's not hard, there's no rocket science here. You build yourself a tool to manage the data properly. So all the data gets input in this information management or building information management tool. And then again, on the back end, we're going to use a web-based platform to allow us to see and parse that information very easily. So this is just an example of the type of web page report that we create now for projects. This is obviously just a small single family project. This is an automated report. So this is rigged up and connected to the PHPP. And the important piece here is that it's a live web page. So all of this data is updated as the PHPP updates. The whole team is able to see the updates in more or less real time as we choose to update them. But the most important part is that it's code. They're not pictures, they're not JPEGs, they're not copy paste, they're not screenshots out of an Excel model. It's code, it's building itself. We don't build the web page. We set up the structure, we feed it the data, and it creates the model every time that we update our PHPP or we update our modeling. It radically improves the amount of time it takes us to create a product like this. In addition, I just want to show here, I like this part very much. We added in a little bit of section here so that we can manage additional data in addition to the stuff that just comes out of the model. We're also able to log things like our inputs. So for instance, I have to keep track of all my wall assemblies, different materials. Well, keep track of it all inside of something like a web page, right? That's going to be better than some dead Dropbox folder. Keep track of communications with our contractor friends. We're able to submit details through them. We can provide links to different products that we might like. All of this, again, is largely automated and live. It's rigged up right to our information model. We're able to do things like shading calculation and again, represent that relatively quickly. Right? The important part here is the data flows very easily from one to the other. We have all our thermal simulations, we have window and door details. All of that stuff can easily get logged in something like a little mini project website here. It's not a big pro course site. It's not very high tech. There's really nothing fancy to it, but it allows us to manage that data really efficiently. And again, the most important thing here is that we're making the computer do the hard work. I'm not very good. I don't pay attention to things very well. I can pay attention once, but as soon as I have to do it again, I start to lose track and I start to screw things up. So I make the computer do all the hard work. Right? You build the structure and you let the data flow and you let the model work. And so I would like to propose that we all need to begin to build those skills. These are critical skills for people who work in front of a computer every day, and they're critical skills if we're ever even going to come close to, as an industry, satisfying the type of demand that we know is coming down the line when it comes to things like building energy retrofits over the next 10, 15, 20 years. So if that's of any interest, let me know. You can send me my email right there. And of course, mostly what I'm interested in is to hear anyone's thoughts or opinions